let me start about the plane. Plane we have to discuss today. Hmm. Let's define the plane first. A locus is said to be a plane. A locus is said to be a plane if it is such that if A and B are any two points, any two points on the locus, then every point on the line, every point on the line joining the points, joining the points A and B is also a point on the locus, on the locus. Suppose this screen is a plane, then if you have taken any 2 points A and B, they are on the plane. That is the definition of the plane. And uh, or next the definition. Plane is a surface. Plane is a surface such that the straight line, the straight line joining any 2 points on it completely lies on the surface. Completely lies on the surface. Now the second part is general form of a plane. Second one is a general form of a plane. General form of a plane. Uh, the general equation of first degree. The general equation of first degree. General equation of first degree. In x, y, z is ax plus by plus c z plus d equal to 0, where a, b, c and d are constants and a, b, c are not simultaneously 0. Simultaneously 0 always represent a plane. Always represent represents a plane. Okay, this is the definition of linear equation, a general form of plane. Then we have to prove that. We have to prove. Second page, I am to move. question. Prove that the general equation of first degree in xyz represents a plane. This is our question. Now we have to prove this. uh, to prove this, first of all, we have to consider a first degree equation in xyz is ax plus by plus cz plus d equal to 0. Where a, b, c, d are constant and a, b, c all are not equal to 0. This is the first part. Then we have to suppose let p x1 y1 z1 and q x2 y2 z2 be any two points on the surface on the surface on the surface represented by 1, represented by 1. Then it becomes ax1 plus by1 plus cz1 plus d equal to 0. This is equation number second. And ax2 plus by2 plus cz2 plus d equal to 0. This is equation number third. We have suppose second and third. Then we can multiply equation second by m2 and equation third by m1 and adding. Then is this to our equation second by m2, equation third by m1 and adding both equation. So what will obtain? Let's check. In this part, a is common, m1 x2 plus m2 x1. A common, m2 x1 plus m1 x2. While adding this two, okay, and plus b times m2 y1 plus m1 y2 plus c times m2 z1 plus m1 z2 plus dm2 m1, okay, plus d is common, m1 plus m2 equal to 0. Okay, d is common, m1 plus m2 by 0. Now I have to shift to the next page, that dividing each term by m1 plus m2, then dividing each terms by m1 plus m2, then we will get what we will get, a times of m1 plus m2 or m2 plus m1. Okay, in order we can write, this is in order also we can write, okay, or m2 plus, sorry, m2 x1 plus m1 x2 over, okay, m2 plus m1, first range m2 and second ratio is m2, m1 we can suppose b times m2 x1 plus m1 x2 over m2 plus m1 plus c times m2 x1 plus m, oh, this is y, and this is z, m1 z2 by m2 plus m1 plus d equal to 0. This is d, this is d equal to 0. So this is y1, this is y2, m2 y1 and y2, m1 y2. Yeah, then this shows ax by cz plus d equal to 0. In that pattern we obtain, which shows that the point, these three coordinates, x y z coordinates, that is m2 x1 plus m1 x2 by m2 plus m1 comma m2 y1 plus m1 y2 by m2 plus m1 comma m2 z1 plus m1 z2 over m2 plus m1. This is a point lies on the locus represented by the equation 1. Then after that again this point lies on the line joining the points p x1 comma y1 comma z1 and q x2 comma y2 comma z2 and divides in the ratio m2 is to m1. Yes. Now by the definition the plane the locus of the equation 1 the locus of the equation 1 is a plane hence the general equation of first degree in xyz represents of a plane in this way we can prove हामीले प्रुभ गर्न सक्छौं यसरी हामीले प्रुभ गर्न सक्छौं र कहीं तिम्रो k:1 को रेशियोमा पनि मानेको हुन्छ k:1 को रेशियोमा मानेको हुन सक्छ k ले मल्टिप्लाई गर्ने एड गर्ने गर्न सक्छ त्यो बेलामा k को भ्यालु के हुनु हुँदैन -1 हुनुहुन्न किनभने k + 1 मा k को भ्यालु -1 हुने बित्तिकै यो इन्फिनिटी हुन्छ त्यसकारण त्यो कुरा जनरलाइज गर्नुपर्छ अब यसलाई अलिकति हामीले बुझ्दाखेरि के छ भन्दाखेरि दुईटा पोइन्टहरु भयो हैन यो प्लेनमा भएको दुईटा पोइन्टहरु छन् x1, y1, z र अब q चाहिँ x2, y2, z2 भन्ने दुईटा पोइन्टहरु छन् अब m2:m1 को रेशियोमा एउटा पोइन्टले काटेको छ र त्यो r भन्ने पोइन्टको कोअर्डिनेट्स हामीले के फाइन्ड आउट गर्यौं भर्खरै हामीले हेरौं त त्यो पोइन्टहरु चाहिँ m2x1 + m1x2 / m2 + m1 अब यसमा चाहिँ के रह्यो भन्दाखेरि हाम्रो m2x1 + m1x2 / m2 + m1 अनि m2y1 + m1y2 / m2 + m1 कमा m2yz1 + m1z2 / m2 + m1 अब यो तीनटा यसबाट के भयो भन्दाखेरि एउटा प्लेनमा भएका दुईटा पोइन्टहरु बाट लिए एउटा हामीले कुनै एउटा पोइन्ट लियौं जुन चाहिँ के छ m2 m1 को रेशियोमा कट गर्ने पोइन्ट छ त्यही लाइनमा त्यही लोकसमा पर्छ फेरि दुईटा बीचमा लियो यही पर्छ यो दुईटा बीचमा लियो यही पर्छ यो दुईटा बीचमा लियो यही पर्छ भन्छ नि यो लोकस अफ द पोइन्ट्स कहाँ पर्यो pq पोइन्ट्समा पर्यो पछाडी के भयो यो पनि सरफेसमै पर्यो हैन यसरी चाहिँ एभ्री इक्वेसन अफ फर्स्ट डिग्री इन xyz रिप्रेजेन्ट्स अ प्लेन यसरी हामी p x1 y1 z and q x2 y2 z on the locus also lies on the locus त्यस कारण चाहिँ लोकस रिप्रेजेन्ट अ प्लेन यसरी हामीले बुझ्नु पर्छ यसलाई हामी क्लियर गर्न सक्छौं